Hello and welcome back to the challenge. My name is Piyush. This is day 8 in 30 days of AWS Terraform, and in this video we'll be looking into meta arguments in Terraform. Now we'll be looking into the specifics of it. Why do we need it? What are different type of meta arguments? And then we'll be do the practical demo of each one of those. Plus in the GitHub repository of day 8 folder you will find the task.md file in which you can start doing the practice from this video, and also you can participate in 30 days of AWS Terraform. If you don't know about the challenge, I would highly recommend watching day 0 video for the specifics. And yeah, let's get into the video. By the way, my throat is little sore. I was under the weather, so you will find me sipping through this homemade tea throughout this video. So if I do that, it's not to disrespect anyone or not to disrespect your time. It just I'm unable to talk right now, and this is the only thing that is giving me relief. So I was not planning to record the video, but then it's been too long. You won't be probably noticing it because you are getting videos daily, because I'm publishing daily, but I have recorded these videos in batches, and if I did not do it today, I probably have to wait for a few more days till I'm better. So that's why yeah, this okay. So yeah, bear with me on that, please. So let's start with the content of this video. What are we going to cover? In Terraform, like we have arguments, right? We have, when we have created the resources, let's take an example of this resource over here, right? So there's as a resource type AWS security group rule. It has different arguments over here, and you can find the argument reference in the same documentation, like what are the mandatory ones, what are the optional ones, and the type of those arguments and so on, right? But then there are certain meta arguments as well that is provided by Terraform. So these arguments are provided by the provider itself. Provider here is AWS. So these arguments are provided by provider, but the meta arguments, these are provided by Terraform itself to support the arguments. Okay, so it makes life easy. That's the simplest definition of it. When you use it, you will find it really easy to implement certain logic in your Terraform configuration without writing an external script, and I will show you everything about that. So there are multiple meta arguments. First is depends on, as the name suggests, it establishes the dependency between multiple resources. So let's say you have 10 different resources in a Terraform file. Okay, how would Terraform know which resource to provision first? And if you have 10 different files, which file to be executed first? So if we have multiple files, then Terraform executes or loads those files in the alphabetical order. But if you have a single file with multiple resources, there is no way for Terraform to know which resource to be created first. Like, let's say you have created VPC and then instance and then security group. So you want that instance should be created after the VPC. How do we set the dependency, right? So there is implicit dependency, which we'll talk about later, and then there is explicit dependency. So explicit dependency is a type of meta argument in which we define that resource B is dependent on resource A. So Terraform will wait for the provisioning of resource B till the resource A is created, right? So as you can see, we have set the dependency between resource A and B. So first it will provision resource A. Once it is created, then it will say to Terraform, okay, the resource A is created. Now you can go ahead and create resource B, right? So that's explicit dependency. The next meta argument is count. Count, as the name suggests, it helps you count the values, or you can call it iterator. It actually works as a function, but it's not a function, it's a meta argument, and it helps you count values in a list or set or map, and then we can use those values later on, right? For each is a kind of for loop for Terraform, which iterate through multiple values one by one. For example, you have a list of strings, right? Let's say that string has 3 elements. So it will iterate from 0th index to first index to second index to get some values or to do some manipulation. So it's basically works similarly like how for loop work. But if you have not worked with for loop earlier, or if you are new to programming and something, that's fine too. I will explain everything with the help of example as well. Now we have provider, which is basically a plugin. This we have already covered earlier. Then we have life cycle rules. So this life cycle meta argument probably will not be covering in this video, otherwise it will be too much. So in this video we'll be covering depends on, count, and for each. Life cycle will cover in the next video. Okay, so let's start with the demo then. All right, so I have logged into my VS Code terminal. uh, Let me create a new folder over here, day 8, and I'm gonna copy backend.tf and provider.tf, terraform tf and variable.tf, output.tf as well, from this file, from this folder, day 7 to day 8. So I'm gonna copy it over here. Okay, now let's go inside day 8. All right, now we don't have main.tf, so let's start with main.tf. So what we're gonna do first, we're gonna see how count works in Terraform. Okay, so let's say you have a resource AWS S3 bucket. Okay, now we have created the S3 bucket before as well, so I hope you are aware of the important fields. So we start with the resource type AWS S3 bucket. We give it a simple name, so let's call it bucket1. Okay, so this name is internal to Terraform. It's not the name of the resource, it's just the internal name that using which we'll be referring this bucket internally within Terraform. Okay, now this is the bucket name over here. Okay, you won't probably see it because I haven't added it. Okay, so let's remove these fields for now. So when we add when we need bucket, so it will be bucket equal to we just provide this a unique name. Let's call it my unique bucket, blah blah blah, so on, right? Now okay, let's add some tags as well. Let's copy the tags from the previous video. Okay, previous video we created actually a variable. So if we go to variables.tf and if we see, let's see where are the tags. So that was a map variable tags, and it has environment, name, and created by, right? So let's go over here and we can just specify var dot common tags. Was it common tags? Var dot tags was the name actually. Okay, so that's just the simplest possible example. Now it is throwing error, maybe because there is some issue with it. Now what is the issue? Let's see. We have provider defined over here, and in main.tf we have AWS S3 bucket. Let's go and check the documentation. Whenever we face an issue, the first place that we should be going is the documentation. S3 bucket. Okay, let's see. Okay, no, that's the data source. Data source we'll cover later on, so don't worry about it yet. But for now we need S3 bucket resource. Okay, AWS S3 bucket. Okay, so the sample, oh, I forgot the resource keyword before the resource type. Okay, now this is how it should be: resource and then the resource type and then the internal name. Now if I over here, if I run Terraform init and then Terraform plan, what it will show? It will show that an S3 bucket will be created with this name and with those 3 tags, right? So if I do tf plan now, let's see. Okay, one plan to add, and there are some metadata to it, but these are the main things: tags, and then region is this one, which is the default region, and here is the bucket name, right? But what if I have to create multiple buckets using the same configuration, right? So what we can do is there are multiple ways of doing that, and one way is using count. Okay, so let's go to variable.tf and let's create another variable. Let's call it bucket name or bucket names, right? And in this bucket name, now we have multiple options. We can either create a list of string, we can create a set of string, and we can also create map of string. So let me show you all those things. Okay, so if the bucket name, we have created a list of string, it has multiple values, let's say these two values. So these two bucket will be created with just that one block. And how we gonna do that? Let's see. Let's go to main.tf. Now we don't need the bucket name over here. Okay, what we need to read the bucket name but from the variable itself, right? That's one way. Like if we know that we just need the first element because it's a list, we can just get the first element. But if we want to iterate through all those elements and we create, if we need to use all the elements in the list. So what we'll do is we'll add another variable called count, and let's say count equal to 2. And over here, instead of var.bucket name, right, so we just write var.bucket name, and now the count is not 0, right, because we need to create two buckets, but we don't need to hard code it like 0 or 1. So what do? Inside the square bracket we use count.index. Now what it will do, first it will come here. Okay, count is 2, but then it will always start with 0th index, right? So count is index starting with 0. Okay, over here this will be the value of first element which is at the 0th index. Then it will increment the counter again. Now the count will become 2 because we have to iterate it twice, right? So when it goes again, it will iterate it again, and now the count of index will become 1, which is the second element. So first, for the first counter it will take this element, for the second counter it will take this element, right? So now the bucket name will be both. Let's see what do we do. So let's run tfplan again. Okay, now you see it says to add. So there is this bucket with the name ending with day 08, my unique bucket day 08 1 2 3 4 5 6 2. And then there is another bucket which is day 08 1 2 3 4 5 6 1. It has 2 in the end, the first bucket has 1 in the end. So these both are separate buckets, and we only wrote the Terraform resource definition once. So there is only one definition, and using the same we are creating multiple buckets. Now we can increase this count and add more values to the list, and it will add more values, right? Now what if there is, instead of list, let's create another variable over here, but this time let's use set. Instead of list, let's use set. And now let's use 0 at the end and 9 at this bucket name, because bucket name has to be unique, right? Now let's go back over here. Now if we need to use, okay, what's the variable name? Did we use the same name? No, let's not use the same name. Let's call it bucket name set. Okay, and yeah, that's all right. Let's go back. Now instead of var.bucket name, let me just comment this value. Use bucket is equal to var dot bucket name set. Okay, now if we use count.index, it will not work. Why it will not work? Because if you remember when we discuss about data type constraints, right, we discussed that set does not have indexes, only list have indexes. So if we want to traverse or if we want to iterate in a set, then count.index would not work over here. Okay, so what we need to do is, let's change this, let's keep it the way it is. Okay, and let's create another resource over here. Resource AWS S3 bucket and let's call it bucket2. Now inside over here we're gonna use another meta argument, which is for each. Okay, so the way it works is for each. Okay, now what do we need? We need the bucket name, right? So AWS, actually we need to use length function over here with var dot bucket name set. Okay, I think this should work, but let's see. And over here now we need the bucket name. So what a bucket name, how we did get it? So var dot bucket name hyphen set, and inside curly braces we'll use each dot key over here. Right, key or value both will work, and I will explain it why would it happen. So now, okay, it's suggesting something. What is this? Maybe we don't have to provide the entire variable name. That's what it is saying. But let's see if it's gonna throw the error or not. So what did we do? There is a set, right, which we have created. In the set is of type string, and in that we have two elements. Now because it's a set, it's not a list, we cannot iterate through the elements of the set. So what we need to do is we need to use for each for that. Okay, now for each is a counter, right? It needs a counter. We need to initialize the counter and have it run for a certain time. So that's why we have used length function to calculate the length of this set. If you don't want to use the length function, you can just write for each equal to 2 over here, right? That means just run it twice, run it 2 times. If the set has 3 elements, so just use it 3. But this is the easier way, right? You don't have to hardcore anything in this way. So you are calculating the length of elements in the bucket name set variable. All right. So this, let's say this will be 2 for now. Now you need to set the bucket name. Now again, for the bucket name, you have to traverse through each of those values. So that's why you have used each dot key or each dot value. Now each dot key is there, which means first it will traverse through the first element, not from the index but from the length. Like order doesn't matter in the set, order doesn't matter in the list, it matters because it has to go through 0th element first and second, right? But in set, order doesn't matter of the elements. So that's why it will traverse through each of the elements one by one, but it will traverse only twice. So first time it will set the bucket value to the first element, second time it will set it second one. So if we run tfplan now, let's see. Okay, now it is throwing the error. It is saying bucket.name.set is a set of string. So the suggestion that it was saying earlier, remove this var and we can directly access it with each dot key. Let's run tfplan again. Okay, it says for each argument is unsuitable. The for each argument must be a map or set of strings, and you have provided a value of type number. Oh, okay, because it's length. Okay, and what if we do each dot value? Again, it is saying it is of type number, because in for each it is taking as 1 and each dot value is, I mean, it's just taking the number, it's not taking the bucket name. So somehow it is not traversing through it. That means we don't need the length over here, right? Because it has to traverse through the elements. There is no index over here. Like in set, we were using index. That's why, like, we can use length over here. Like instead of count, what we can do is we can just use length of var dot bucket names over here, right? It should work fine. It will set the count as 2, but over here it cannot calculate the length because there is no indexes in set, right? So how do we calculate? We just directly refer it with the variable name. Okay, now it will set the value of for each of those elements of the set. Okay, now that's for each equal to bucket name set and then bucket equal to each dot value and tags are tags. Okay, so let's do that. Okay, now it is not throwing any error. It says 4 plans to add. the last two buckets that we have added ended with a number 9 and then number 0, which is over here, right? And rest two buckets are also there. So try to understand the difference between these two. Okay, so there is count. Okay, the way count works, count will work on list, but this for each will work on set or map as well. I will show you map as well. What will happen if I replace each dot value with each dot key? Okay, I just want to show you this thing as well. So let's run tfplan again. Nothing changed, right? So as you can see, still there is this S3 bucket and then there is this S3 bucket. Nothing changed. So what's the difference? In set, there is no difference. You can use each dot key or each dot value. The difference will come when we use map. Why? Because in map only there is a key and then there is a value. Okay, so if you remember in the previous day what we did, so there is list of string, let's say, okay, which is something like this. List of a string hello, that's first element, word, that's second element. Okay, so that's a list of string. Similarly, we have set of string. Set of string, it will look same, but it's not the same. And let me just add the values first. Hello world. Okay, the difference is in this list of string you can access the element from, let's say, list of 0 and list of 1, right? That's how you can access the elements in the list, but you cannot do the same with set of strings. If you want to access the element 0 1, it will not work. So you have to use some sort of counter which will go through one element one by one. Okay, so that is why for that we use for each. Now in this set of string or list of string, there are only values. There is no key, right? So there is variable. Over here is the variable and over here is the value. There is no key or value, right? So that's why in list and string, key and value are same. So this is the key and value. If you access it like for each dot key, then it will represent hello. If it will write each dot value, then it will say the same. But when we have something called as map, so the way map works is we have sort of a JSON syntax for it, right? So let's say name is equal to 𝗵𝗆 and series is equal to Terraform. Now this has two elements. This map of string has two elements. First, this is the key, this is the value. Or let me just write it down in the next line so that it will become more clear. Right, this will look something like this. So we have a key which is name, value is 𝗵𝗆, key and value. So in map we can use each dot key and each dot value. Okay, but not for list and string. That's the main difference between using each dot key and each dot value. So we have covered count and for each. Now the next is dependency. Okay, so now you see, let's see the status, like the sequence of these buckets that's been created. So we have tfplan and let's just grab only the line in which it says will be created. Okay, so I just need this line. So let me just grab for this string. So the way it is creating, why does it say bucket 1 0 and bucket 1? Okay, so yeah, we shouldn't be using length over here as well. So as what I said earlier, please forget that. I'm not feeling well. You see. Okay, so count, let's keep it 2 again. Okay. Again, it is showing the same thing. Bucket name var dot bucket name count dot index. Yeah, I don't think it matters. Let's try to create the bucket and see if it is actually showing it just like to refer the element of the list, or it is actually using a fake name. So let's try it to apply auto approve. Okay. Okay, it created 4 resources and the name is creating bucket 1. So bucket 1, oh no, it used the right name, right? Bucket 1 is this, and bucket 1 second element, like first element is this, second element is this. But if you see the sequence, it started creating bucket 1 0 and then bucket 2. Ideally it should have created in the same sequence the way we have written it, right? So how do we control that? First, let's destroy these resources. Auto approve. Okay, and now while it is running the command, we'll set something called as dependency between these resources. Okay, so what we'll do is in this bucket over here, we'll add another meta argument depends on. Okay, depends on, and then in the square bracket we will give the reference of the resource that this is dependent on. Okay, so we are saying AWS S3 bucket is dependent on AWS S3 bucket dot bucket 1. So once these 2 resources are created, only these 2 resources will be provisioned. So let's try to run TF plan again. And over here you see bucket 1 of 0th element, bucket 1 of 1, and then bucket 2 and then bucket 2. So this is showing correctly. Let's see if it is showing that in apply as well. Okay, so let's see. Bucket 0, bucket 1, creating, bucket 0, bucket 1, creation complete. And once the creation of these 2 buckets are completed, only then it proceeded with bucket 2 creation. So what we did, we set the dependency between multiple resources. We are saying resource 2 is dependent on resource 1. Only create resource 2 once resource A is healthy or once resource A has been created. So that's what we did over here. I think that's all about this video what we wanted to cover. So let me just show you the GitHub repo as well for day 8. Okay, so that's like whatever we did code will be here as well on the repository, and it has the example of lifecycle meta argument, but this will cover in the next video. Now there is task.md file over here, so make sure you practice these things to understand. If you don't practice, if you just watch the video, you will not get any benefit out of it, right? So make sure you practice these tasks and make sure you submit these tasks as part of your assignment for today for 30 days of AWS Terraform. And you can just submit the work. Submission.md file will have the instructions. How do we do that? And I have shared everything in day 0 video as well. So that's it from this video. Thank you so much for watching. I'll see you tomorrow with the next video. I hope you're having a good time. Thank you. Happy learning.